In this presentation, we will explore flip-flop conversions. Specifically, we will discuss the process of converting between different types of flip-flops. Understanding how to convert between SR, D, JK, and T flip-flops is essential for digital circuit design and optimization. Let's dive into the details. Let's begin with a brief overview of the different flip-flop types. We have the SR flip-flop, also known as set-reset, which is a basic latch with a forbidden state. Then there is the D flip-flop or data flip-flop, which eliminates the forbidden state. The JK flip-flop, named after Jack Kilby, is a universal flip-flop. Lastly, the T flip-flop or toggle flip-flop complements its output. Now let's look at converting an SR flip-flop to a JK flip-flop. Here's the conversion table. When J and K are both 0, S and R are 0. When J is 0 and K is 1, S is 0 and R is 1. When J is 1 and K is 0, S is 1 and R is 0. And when J and K are both 1, S and R are 0. Using this table, we can derive the formulas S equals J and Q bar, and R equals K and Q. Next, we'll discuss converting a JK flip-flop to a D flip-flop. Here's the conversion table. When D is 0, J is 0 and K is 1. When D is 1, J is 1 and K is 0. From this, we derive the formulas J equals D and K equals D bar. Let's consider the conversion from a D flip-flop to a T flip-flop. The table shows the relationship between T, the current state Q subscript N, the next state Q subscript N plus 1, and D. When T is 0 and Q subscript N is 0, Q subscript N plus 1 is 0 and D is 0. When T is 0 and Q subscript N is 1, Q subscript N plus 1 is 1 and D is 1. When T is 1 and Q subscript N is 0, Q subscript N plus 1 is 1 and D is 1. Finally, when T is 1 and Q subscript N is 1, Q subscript N plus 1 is 0 and D is 0. From this table, we can derive the formula D equals T XOR Q subscript N. Now let's explore converting a T flip-flop to a JK flip-flop. The conversion table is as follows. When T is 0, J and K are both 0. When T is 1, J and K are both 1. Therefore, the formulas are J equals T and K equals T. Here is an example of a conversion circuit, which converts JK flip-flop to D flip-flop using complementary inputs. As shown in the diagram, D is connected to J. With the NOT gate, D bar is connected to K. The output is Q. In summary, here are the conversion formulas we've discussed. To convert from SR to JK, S equals J and Q bar, and R equals K and Q. To convert from JK to D, J equals D and K equals D bar. To convert from D to T, D equals T XOR Q subscript N. And to convert from T to JK, J equals T and K equals T. The JK flip-flop is the most versatile and can implement any other flip-flop type. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.